volumetric analysis. We're going to specifically look at concentrations of solutions, specifically in moles per litre and grams per litre. So our learning intention is to express concentration of a solution in moles per litre and grams per litre, and to undertake a variety of calculations including simple percentage concentrations, molarity, from concentration in grams, and vice versa, along with the number of moles from molarity and volume. So our first calculation is molarity, and molarity is moles of solute per litre of solution. So here's the definition. Molarity of a solution is the number of moles of solute per litre. It's given the symbol capital M, or moles per litre, and a 1 molar solution contains 1 mole of solute per litre of solution. So for example, a 1 molar hydrochloric acid solution contains 1 mole, which is 36.5 grams of hydrochloric acid per litre. And it's important to remember, when you're working with molarity, you will go from grams to moles, you divide by molecular mass, and to go from moles to grams, you multiply by it. So if we look at an example, it says a solution contains 4 grams of sodium hydroxide in 250 centimetres cubed. What is the concentration of the solution in moles per litre? So to start, what I would say here is that we have grams per 250 centimetres cubed, and we want to go to moles per litre, or capital M. So the first thing would be there's 4 grams per 250 centimetres cubed. So what I would do here is I would divide by 250, and that gives me 0.016 grams per 1 centimetre cubed. And then I would multiply by 1000, because there's 1000 centimetres cubed in a litre, and that gives me 16 grams per litre. Now, some of you will have spotted that here you could just simply multiply the 4 grams by 4, because there's 4 250 centimetre cubes in a litre, and that's perfectly fine. Next thing what you want to do, to go from grams to moles, you divide by the molecular mass, and the molecular mass of sodium hydroxide is 23 plus 16 plus 1, so that leaves me with 40. So to go from grams to moles, you divide by the molecular mass. So here I'm going to divide by the molecular mass, which is 40, and that will give me an answer of 0.4 moles per litre. And that's that calculation complete. So this next calculation, it's concentration in grams per litre, and it's just an extension of molarity. So the example says, calculate the concentration in grams per litre of potassium hydroxide solution whose concentration is 0.01 moles per litre. So the first thing I would say here is I would say that 0.01 m is the same as 0.01 moles per litre. So I have the per litre part for grams per litre. Now I just need to get the grams. So I know that if I want to go from moles to grams, that you multiply by the molecular mass. So I will find the molecular mass of the potassium hydroxide, and that is 39 plus 16 plus 1, which is 56. And to go from moles to grams, you multiply by the MR, as I've said. So I'm going to multiply the 0.01 by 56, and that gives me 0.56 grams per litre, and that's that example complete. The next type of calculation that we'll discuss is number of moles given the volume and the molarity, and this one actually involves using a formula. So you can calculate the number of moles by doing the volume by the molarity divided by 1000, and the important thing is that the volume is in centimetres cubed. So let's look at an example. So this example says, what volume of 0.15 molar NaOH solution will contain 5 grams of NaOH? So the first thing I would say is write down your formula. which is moles equals volume by molarity divided by 1,000. So we can see that we have the molarity in the question already. The molarity is 0.15. We're looking for the volume, but we don't have the number of moles. Instead, we have grams. So we need to see the number of moles that's in 5 grams of NaOH. So to go from grams to moles, we know that we must divide by the molecular mass. So the molecular mass of NaOH is 23 plus 16 plus 1, which is 40. So we will do the 5 grams divided by the 40, and that will give us 0.125 moles. So at this point now, we have everything that we need to fill into our formula. So we can say 0.125 moles equals volume, I'm just going to label it V, multiplied by the molarity, which is 0.15, and we're going to divide that by 1,000. So to get volume on its own, you need to rearrange. So we'll have 0.125 multiplied by 1,000 over 0.15, and that's equal to the volume. So volume is equal to 833.33 centimetres cubed. And that's that example complete. And in the next example, we're actually going to look at a problem that has a balanced equation that we need to use to be able to solve. So the question says sodium carbonate, Na2CO3, reacts with dilute hydrochloric acid according to the equation below. What volume of hydrochloric acid of concentration 0.75 moles would be needed to neutralise 7.5 grams of the anhydrous sodium carbonate? So the first thing I would do is I would write down my formula, and my formula is moles equals volume by molarity, which is capital M, and divide that by 1,000. So here it's very clear in the question that we're working with hydrochloric acid, but they give us the number of grams of sodium carbonate. So the first step I would say here is to find the moles of your sodium carbonate. So to do that, we're going from grams to moles, and that means we're going to divide by the molecular mass. And I know that that's 106. So I'm going to do 7.5 divided by 106, and that gives me 0.071 moles of my sodium carbonate, my Na2CO3. So the next step would be to look at your balanced equation, and I can see that it's Na2CO3 plus 2HCl. So I can see that that's a 1:2 ratio, but I don't have 1 mole of my sodium carbonate, I only have 0.071, but I know that I have twice as much hydrochloric acid, so that's 0.142. So I know now that I have 0.142 moles of the HCl. So moving on to step 3 now, we would use our formula. So the number of moles of the hydrochloric acid is 0.142 moles. We're looking for the volume, so I'm going to label that V. The molarity of the hydrochloric acid is 0.75 according to our question, and we divide that by 1,000. So to get V on its own, we have to rearrange. So we do the 0.142 and we multiply that by 1,000 over 0.75. And that gives me that the volume is equal to 189.33 centimetres cubed. And that is our answer to this question. One thing I would point out here is that step 1 and 2 here are very similar to kind of first principles vibes for titrations, which follows in another video. So hopefully your understanding will develop as we move through the videos. So that's it for this video. Make sure to read the learning intentions to understand everything we've gone through.